So we're talking about NAPLs. We've talked about how difficult it is to predict where those NAPLs are going to go. So then maybe prediction's not the way we should go. Maybe what we should do is use real evidence from the field. So here we're going to take a landscape, and here's a water table, and then someone spilled some NAPLs. Now notice that I've drawn these NAPLs floating on what's called the capillary fringe. The capillary fringe is that chunk of soil above zero pressure, which is still saturated with water. And we can think back to our characteristic curves. There's that section of the characteristic curve where air had yet to enter. So the NAPLs actually float high. Now, if we throw a well into this problem, let's put a little observation well here. Here's our observation well. And if there were no NAPL, we'd of course have the water table would settle exactly in our well there. That's the definition of a water table. Everything's fine. But there's this NAPL that's being supported above this. And so what happens is the NAPL then drains into the well. And the NAPL is going to fill much of the well because the buoyant force, this water is denser than the NAPL, and so it is supporting the NAPL, but it has to support this extra chunk of NAPL that's above the water table. So what happens is it pushes the water down. Typically, this will depress this. If this has a distance of h, then this will be something, to this point, will be something like 8 times h, okay? So it really pushes down. So the problem with that is then that if we observe our NAPL level, we go to the well, we've drilled the well, we observe the NAPL level in the well, we say, oh my gosh, there's 9 units of NAPL there. Whereas actually there was just a very, very thin film of NAPL above the capillary fringe that had poured in. And so this might be just a few centimeters thick. And this might be many meters. So the lesson is, unfortunately, that when you observe in the field a well that has a lot of NAPL in it, that does not actually prove the amount of NAPL in that local environment, because the NAPL is supported by the capillary fringe, pours in, and depresses the water level in the well. Once again, NAPLs are complicated, and so when you're in the field, you have to use multiple lines of evidence. And so in this case, doing a coring of the site to see exactly where the NAPL was is more accurate than simply having a well in which you observe the apparent NAPL level.